So we have the Laplace transform table actually. The Laplace transform of 1 is 1 over s. If it is 3, it's 3 over s. If it is 5, it is 5 over s. Laplace transform of t is 1 over s square. 1 over s what? Square. Laplace transform of t raised to the power n is n factorial over s raised to the power n plus 1 factorial n plus 1. Now see, if this thing was 4, this thing would have been 4 factorial over s raised to the power 4 plus 1, which is 5. So that means it's 4 factorial over s raised to the power 5. You can also say 24 over s raised to the power 5, which, because 4 factorial is 4 times 3 times 2 times 1, which is 24 over s raised to the power 5. The Laplace transform of exponential at is 1 over s minus a. If you put 3 here, you become s minus 3. If I put, let's say this is 40, s minus 40. If it's exponential minus 70, it will be s minus 7. Because there's a minus sign there. It will become s minus 7, which is what? S plus 7. So 1 over s plus 7. Cos bt, it is s over s squared plus b squared. If this thing is 4, it will become s squared plus 4 squared, which is 16. That's s squared plus 16. If this thing is minus 2, it's still the same thing. It will be minus 2 times square, which is still 4. And if okay, I think that's all for that one. So going to the next one, the same thing applies to all of them. So see this one also, same thing applies. This one, if you have exponential at, this is one of the places that people normally make mistakes. If you have exponential at, f of t, know very well this is not the definition of Laplace. In the definition of Laplace, what we have is minus st. In this case, we have at. So now this thing will be f of s minus a. We call this shifting theorem. Shifting theorem. So whenever exponential at multiplies any Laplace transform standard equation, the s is shifted by a. Instead of you having s, you have s minus a. Now, assuming that in this case now, I have exponential at times sine bt. This thing would have been, I will come here, this place I have s now, I'll have s minus a, all raised to the power 2. If it was, like in this case now, you see that the s here is shifted minus a. If it's exponential at, in this case now, exponential at t raised to the power n, this thing would have been s minus a, all raised to the power n plus 1. So that's how it works. So moving forward, let's look at some questions again. Before we start using the table proper, let's still look at how, or let's say how the formulas were proven. Yeah. So we want to look at Laplace transform of exponential at, assuming you were asked to solve it in exam, how it was proven. You will see that, as I told you earlier, definition of Laplace is integral from 0 to infinity exponential minus st f of t. Our f of t here now is what? Exponential at. Yeah. So you have this, and then this is same base with this. Add the powers from indices. You become minus st plus at. When you factor out t, you have this. When you factor out t and minus, you have this. You get. So when you integrate, of course, integration of exponential, let's say 40, would mean dividing it by 4. When you have this one now that is minus s minus a, then you have this thing now as a whole. We divide it instead of, but that time it was a number, now it's now a big something, to divide it as well. That's where you have this when you integrate it. So 0 to infinity as usual. You will have 0 to infinity. So you put infinity first. You put infinity here. This will be exponential infinity, and exponential infinity is 0. So it will carry everything to 0. Then minus, you put 0 now in the next one. If you put 0 as our t here, it will be exponential 0. and exponential 0 is what? Is 1. So you have 1 over minus s minus a. But remember, there was a minus in front before you did this one. So it will now make it to become s minus a. So that minus will go. So that's it. So you can check out for this other one. If you look here, you see how this one is that of cos bt. So the function here now f of t, according to Laplace definition, is cos bt. So when you have this now, moving forward, this particular thing now, cos bt is something as exponential ibt. So when you solve this as well, you arrive at this particular part. I wouldn't explain that much. We need to move to the next thing.